When people first learn AWS networking, they usually ask one question. Does the VPC work? Can the application reach the internet? Can users open the website? Can the servers talk to the database? Those are important questions, but senior engineers go a little further. They ask, what happens when traffic increases? What happens if one part fails? Is the design secure? And will it become expensive as the system grows? So, in this video, we are going to review this VPC the way an experienced engineer would. We will first understand the current design, then we will look for bottlenecks, risks, cost problems, and security gaps. Finally, we will improve the architecture so it is more suitable for production. The goal is not to make the network complicated. The goal is to make it reliable, secure, and easy to understand. The first thing a senior engineer does is slow down and understand the design. Before we suggest changes, we need to know what every part of the VPC is doing. Here, we have a public subnet, a private application subnet, and a private database subnet. The public subnet contains resources that may need direct access to the internet, such as an internet-facing load balancer or a NAT gateway. The application servers are in a private subnet. This means users should not connect directly to those servers from the internet. The database is placed in another private subnet because it should only receive traffic from the application layer. We also check the route tables. This is very important because the name of a subnet does not make it public or private. The route table decides where the traffic can go. We check the CIDR ranges, security groups, network ACLs, and the path traffic follows through the system. At this stage, we are simply trying to answer one question. Do we clearly understand how this network works? Because if the design is confusing on paper, it will be even more confusing when something fails in production. Once the design is clear, we start looking for problems. The first question is, where can this architecture fail? For example, this design has one NAT gateway. That may work for a small environment, but if every private server depends on it, it becomes an important part of the system. If that availability zone has a problem, outbound traffic may stop. A NAT gateway can also become expensive when large amounts of data pass through it. Next, we check the security groups. A rule such as 0.0.0.0/0 means traffic is allowed from anywhere. Sometimes that is necessary, but it should never be added without understanding the risk. We also look at the route tables. If many subnets share the same route table, one small change could affect several workloads at the same time. Then we check whether the application is running in only one availability zone. If the whole system depends on one zone, an outage could take down the service. Finally, we look at visibility. Without VPC flow logs and monitoring, the team may not know why traffic is being blocked or where unusual traffic is coming from. This part of the review is about finding problems early before users experience them. Now that we understand the risks, we can improve the design. The first improvement is resilience. Instead of placing everything in one availability zone, we can spread the application across two zones. This means the service can continue running even if one zone has a problem. We can also create separate public, application, and database subnets in each zone. Next, we improve security. The load balancer should only accept the traffic it needs. The application servers should only accept traffic from the load balancer, and the database should only accept traffic from the application servers. This is called least privilege access. We can also use separate route tables so that each type of subnet has a clear and predictable traffic path. VPC endpoints can help private resources connect to services such as Amazon S3 or CloudWatch without sending all that traffic through a NAT gateway. This can improve privacy and may also reduce cost. Finally, we enable VPC flow logs, monitoring, alerts, and consistent tagging. These controls make the network easier to troubleshoot, manage, and improve over time. A production-ready VPC is not simply a collection of AWS resources. It is a network designed to keep working, remain secure, and support the application as it grows.